Okay guys, hopefully this is not upside down. So this is section 3.2, and section 3.2, we're gonna learn about 3 ways to prove triangles are congruent. Because again, we don't know if triangles are congruent unless you guys can prove it, okay? I have 2 goals for us. So this is how I'm gonna set my notes up. Goal number 1 is to be able to identify included angles and included sides, okay? Goal 2 is to be able to apply this postulate, which we haven't gotten to yet. But let's start with goal number 1, included angles and included sides. So if you guys were looking at this triangle and I asked you guys what angle is included with side AB and side AC. So what I would do is I would actually trace AB and I would trace AC, and I'm asking you guys what angle is included. So if you were to smash those together, what angle is kind of being formed by them? And I know this is very obvious because they both have the letter in their names, but you should be thinking angle A is included. It's in between those 2 sides. This angle right here, if you were to, this angle is the only angle that's touching both the blue and the pink. Angle B is only touching the blue, and angle C is only touching the pink. Okay, so that is my included angle. To go over another example with you guys, if you were to look down here, what angle is included in BC and CA? And you can see that that is angle C. Okay, that is how you find the included angle. And that's important when I start talking about included angles later on. Next is an included side. So let's say I'm asking you guys, what side is included in angle A? So what I would do is trace angle A and angle B. So let's trace angle B. What side has both colors overlapping? Side AB. Okay, segment AB. That's the segment out of those 3 segments, that's the only one that has both colors. So that is the included side. Okay, again, let's take a look at the next one. If I said what side is included in angle C and angle B, could have used different colors here, angle C and angle B, that would be side BC. That is the included side. Okay, so that word included is huge here. Okay, so that is step 1, making sure you guys understand when I say the included side or the included angle. Step 2, we're going to be talking about some theorems. Okay, so let's say I gave you guys these 3 pieces of spaghetti and I asked you guys to make a triangle with these, right? So you can actually take this and turn it, rotate it if you could. I'll take this one over here. That's 10, this one's 7, we're just pretending. I don't know why I can't. Here we go. I'm trying to keep it the same size. And I did this, and then I cut this one out, and I took this, okay? There is only, so here's the 10, here's the 7, and here's the 4. There is only one triangle that you're able to make with these sides. I understand that, you know, yours might be upside down. You might have a 4 here, a 7 here, and a 10 here, but these triangles will all exactly be the same. If you were to cut them out and spin them, all of them would eventually fit on top of each other, okay? Whenever you have 3 sides that are congruent, you're only able to make one type of triangle, okay? There's only one different triangle that you can make, which brings me to my first postulate. It is called the side, side, side postulate, okay? From now on, you are allowed to identify congruent triangles if all 3 of the sides match up. In other words, if you can tell me that AB is congruent to AD, and it is, okay, you see tick marks there. If you can tell me that side BC matches up with CD, and it does, you see tick marks there, that's your given information, and if you have a third side, and lucky for us we do, we know that AC is congruent to AC because of the reflexive property. So because we have this side, and this side, we can say then triangle, I'm going to call this triangle BAC, is congruent to triangle. Now again, go back and think about this. I started at B. B is between the pink and the blue side, so I have to start at D. Then I went to A down the pink side, so I'm going to have to go A down the pink side. And then I went to C, so I'm also going to have to go to C. You have to be very careful with this congruent statement, okay? So if all three of the sides match up, we now are able to say that these triangles are congruent, okay? Another example, so let's say you see GHI and JKL. If you saw a picture like this, no, these are not congruent. But let's say you saw the picture and it looks like this. This is enough information to say that these triangles are congruent. Again, what I usually like to do to match them up is I use these highlighters all the time. So if you notice the 1 tick mark, I colored green, the 2 tick marks, I colored orange, and the 3 tick marks, I colored pink. So you can actually see how this was rotated to fit on top of each other. So it's easy for you to see that triangle GHI would be congruent. I started at G, so I have to start at J. JKL, triangle. Put a triangle mark in front of it too. I almost forgot the triangle mark. If you don't put a triangle, I don't know if you're talking about the angle or the whole triangle, because a triangle has 6 parts to it. So this tells me that all 6 of the parts are equal to each other. If you only tell me angle, that's only 1 part. So this means that all the triangle parts are congruent to each other. Okay, the next is called the side angle side postulate. If 2 sides of one triangle, okay, if 2 sides of one triangle and the included angle, look at that. Do you see how the A is in the middle? Okay, I didn't do that on accident. The angle has to be in the middle or included in the 2 sides in order for this to work. Okay, it's like an Oreo. And we call this the side angle side postulate, and you guys are allowed to use SAS. So what this means is, if you can prove to me that you have a side, so if you have a side, and we do, right here, AB is congruent to AD, the included angle, right here, don't tell me angle A, do not tell me angle A. Angle BAC is congruent to angle DAC, not angle A, because there's too many angle A's there. I don't know which one you're talking about. So I have the pink sides are equal. I have the included green angles are equal. And now I need the other side, and I already have it because of the reflexive property. I know that AC is congruent to AC because any segment is congruent to itself. So I can now say then triangle ABC is congruent to triangle ADC. Okay, same holds true over to the side. If you look at this, I have a side and a side. I have the included angle touching the other side and the side. So that means that these triangles are congruent using side angle side. So triangle FGE is congruent to triangle JIH, and that's by side angle side. Okay, the included angle. The last one we're going to talk about is if 2 angles and the included side of the triangle are congruent. Okay, 2 angles and the included side are congruent. This is called angle side angle. Angle side angle. And again, you can see. So if, again, don't tell me angle A, if angle BAC is congruent to angle DAC, and it is, I see the blue little tick marks, and the included side, which we have, AC is congruent to AC, and angle BCA is congruent to angle DCA. Those are the orange ones. So I have the blue angles that are equal to each other. They told me that, okay? They told me that. I have this reflexive side right here, which we are always allowed to pull out, and I have this orange angle equal to this orange angle. Now I can say that these triangles are congruent because of angle side angle. So triangle ABC is congruent to triangle ADC by angle side angle. Okay, same thing with the picture over on the side, just to show you guys quickly. I have angle E equal to angle J. I have angle G equal to angle H, and I have the included side, okay, the side that is touching both of those angles. So I am allowed to say triangle EFG is congruent to triangle, I started at the pink angle, so start at the pink angle, JIH, because of angle side angle. I have enough information to prove the triangles are congruent. Okay, we're going to do some of these examples in class.